Godot's maintainers have been receiving enough low-quality, AI-assisted pull requests that Remy Verschelde described the work as increasingly draining and demoralizing. Jazzband, the Python project collective, shut down after 10 years and said floods of pull requests and AI spam had made its open membership model untenable. So imagine opening a repository on Sunday morning and finding a contribution that compiles, carries a fluent explanation, and may still take longer to disprove than it took someone to generate. Who has spent the scarce resource in that exchange?
The maintainer has. The contributor spent inference and a few minutes of attention. The maintainer owes the project context, review judgment, and the social cost of saying no. And that last cost matters. A plausible patch arrives dressed like work from a person who expects a considered reply. If the submitter can't explain the code when asked, the maintainer has still had to reconstruct the intent, check the edge cases, and decide whether the relationship is worth preserving.
IT Pro's report doesn't claim every project is collapsing. Mike McQuaid at Homebrew says they answer low-effort activity with low effort. Bots close issues, maintainers close without review, and abusive users get blocked. He also thinks the end of open source claim is far too dramatic. Amanda Brock of Open UK gives the harder version. Adoption grew without a matching increase in understanding or funding, and people began expecting service-level support for free because the code was free.
Those positions can both be true. Homebrew has enough institutional confidence to refuse the implied service contract. A smaller library may have one maintainer, 3 earnest contributors, and a reputation built around being welcoming. Automated rejection protects attention, but it also changes who gets through the door. A newcomer with an awkward first patch can resemble a drive-by agent at a glance. The filtering cost doesn't vanish. Some of it becomes the cost of false rejection.
GitHub has started limiting how many pull requests one contributor can keep open, including pull requests opened by agents. That forces a person to choose which changes deserve review before the queue reaches the maintainer. The limit prices attention in the interface where the contribution begins. It also admits something software culture has resisted for years. An open repository isn't an unlimited promise to inspect whatever arrives.
And the AI label alone can't decide quality. An experienced contributor may use a model to prepare a small, well-tested fix and remain accountable for every line. Another person may hand over a huge patch they don't understand. Provenance helps, but ownership is the sharper test. Can the contributor answer questions, revise the change, and remain present after the first review? The repository needs a person attached to the consequences.
That gives us the route today. We'll stay with verification because one of the AI engineer talks proposes a richer meaning for done. After that, there's a wire-level teardown of Grok build, an active copyright fight in Australia, and new software job posting data. We close with a factory that built a memory system around its own records and a video action model for robots.
The opening report also answers a promise from yesterday. We said we'd identify tools that make agent output easier to inspect. Today gives us designs, not a settled answer, and the distinction is useful. A design can make evidence visible. It can't manufacture reviewer time or transfer responsibility away from the person who accepts the work.
Paperclip's creator opens with an agent that submits a pull request and passes the tests. The agent also updates the documentation, closes the issue, and says, "Looks done to me." The talk then separates 3 questions. Is it ready to merge, ready to deploy, or ready to announce to customers? Those are different claims even when the same green check appears beside all 3.
A test result has a wonderfully narrow vocabulary. It can say that this suite, in this environment, returned this result. The trouble begins when a workflow translates that into confidence about rollout, customer impact, or policy compliance. The green check stays visually identical while the claim grows several sizes.
Paperclip's proposed completion record names the artifact and its scope, followed by the standard and the evidence. It also records who verified it, who can approve it, which risk remains, and what happens next. I wouldn't copy that list into every task tracker, but the underlying separation should stay. The producer can claim completion, a verifier can check evidence against a standard, and an authorized person can accept the remaining risk.
Wait. The remaining risk field changes the emotional behavior of the system. Agents are rewarded for reporting a finished state, so uncertainty often gets compressed into a cheerful status. If the handoff requires a statement such as, "The migration passed on 2 database versions. The oldest supported version wasn't tested," uncertainty becomes part of the deliverable. The next person can make a decision without excavating the caveat from a log.
The second AI engineer talk approaches the same problem through continuous integration and delivery. Its author runs a 19-skill agent system with 7 handoffs and says every handoff is a place where the system can lie to you. Her phrasing is blunt, but the mechanism is ordinary. One step writes a file, the next expects a contract, and a missing or malformed output gets mistaken for progress unless the boundary refuses it.
She ends with a line I would put above the door. A gate which logs only warnings is not a gate. A warning preserves throughput and asks a future person to remember the problem. In a fast agent chain, that future person may never see it because 4 later steps have already produced polished output from the bad handoff.
Her 5 controls are contracts, gates, versioning, observability, and recovery. The names come from familiar software practice because the problems are familiar. Validate the output before another process consumes it. Record which prompt and tool version produced it, retain a trace that can explain the state, and make retries safe. Agents add probabilistic behavior and long natural language outputs, but they don't repeal distributed systems mistakes.
I resist one part of the paperclip pitch, though. It suggests using a different model as the verifier, which can help catch independent mistakes, but can also produce 2 systems sharing the same blind spot. Model disagreement is evidence. Model agreement is also evidence. Neither one is the approving authority unless somebody has defined what the evidence proves.
Automated checks can reduce the pile before it reaches a person, and a second model can challenge the first model's explanation. The expensive decision remains, which claims deserve human review, and what sampling rate is acceptable when the volume exceeds anyone's ability to inspect every item. Paperclip makes that decision visible. It doesn't solve the allocation.
That visibility is enough to make the next conversation less slippery. When someone says an agent finished 100 tasks, you can ask whether that means 100 artifacts exist, 100 test suites passed, or 100 authorized people accepted the risk. Those numbers may diverge dramatically, and a single status column hides the difference.
A developer publishing under the name Cereblab captured traffic from Grok Build CLI version 0.2.93 and reports 2 separate channels. Files the agent reads go into the model request and a session archive. Separately, the tool uploaded a Git bundle containing the tracked repository and its history, including a planted file the agent had been explicitly told not to open.
Git history is the detail that changes this. The working tree tells you what the product contains now. The history can contain removed endpoints, old customer names, abandoned experiments, and credentials that were deleted but never purged. A developer may have reviewed today's files for cloud use and still have no idea that a repository snapshot includes yesterday's mistakes.
The author used fake canary secrets and a proxy, then recovered a never-read marker by cloning the captured bundle. A second repository produced the same result. In a separate scale test, the author says a 12 gigabyte repository sent at least 5.1 gigabytes through the storage endpoint before the capture was stopped, while the model requests totaled only 192 kilobytes. That volume difference is the evidence for a repository upload distinct from the files opened during the model turn.
And the analysis is unusually disciplined about its limit. It proves transmission, acceptance by the endpoint, and storage behavior. It doesn't prove that XAI trained on the code. Those are different claims, and collapsing them would make the privacy criticism weaker. The observed behavior is already enough to ask why a coding assistant needs a whole Git bundle when the user requested a tiny task.
The analysis also says turning off Improve the model didn't stop the upload. The server still reported trace and upload settings as enabled. The author only checked the install script and quick start materials, so the documentation claim is limited. This mechanism wasn't surfaced in the setup material reviewed. XAI may have other documentation, and account configurations may differ.
like a training opt-out and a transmission control answer different user questions. One asks whether the company may use your data to improve a model. The other asks which bytes leave your machine for the task you requested. Combining them under one preference gives the user a comforting switch that doesn't describe the boundary they probably care about.
XAI should answer whether the current CLI still uploads a whole bundle, which account types retain it and for how long, and whether a repository scoping control is coming. Until then, the teardown should be read as a reproducible report about version 0.2.93, not a claim about every XAI product or every cloud coding agent.
The product should make the transfer inspectable before it begins. These tracked files, this amount of history, this destination, and this retention policy. Consent gets much easier when it describes an object a developer can recognize. Your code may be processed, is legally broad and operationally vague.
The Guardian reports that Australia's government is split over a text and data mining exemption for AI companies as Anthony Albanese prepares an AI policy speech on Wednesday. The government says it has no plan to weaken copyright. Independent Senator David Pocock says his office was tipped to an industry proposal pairing a copyright carve-out with at least 50 billion Australian dollars in data center investment and a creative fund.
That pairing makes the politics legible. A copyright exemption is an abstract legal mechanism until it sits beside construction spending, power contracts, jobs, and a promise of money for creators. Then every side can describe the same proposal as growth, compensation, or a sale of rights. The categories don't settle the bargain. The terms do.
Atlassian co-founder Scott Farquhar argued last year that fixing copyright could unlock billions in foreign investment. The Attorney General rejected an exemption in October and began consultation on alternatives, including paid licensing. The Guardian says industry and government sources disputed Pocock's account of a specific deal, while also reporting that frontier AI companies see Australian copyright law as a major barrier to training investment.
I understand why a training company wants predictable access to a large corpus. Negotiating work by work is slow, and legal uncertainty can make a country unattractive for model development. Creators hear a different proposition. The inability to license every work cheaply becomes the justification for changing the right itself, and the data center becomes the payment offered to the country rather than to each person whose work enters the training set.
Former Industry Minister Ed Husic says Australia has negotiating leverage and shouldn't treat the investment offer like a late-night infomercial. Other Labour members worry that resisting data centres will send investment elsewhere. The government has already said developers should secure additional green energy and cover their share of transmission and distribution costs. Copyright is now being argued inside that broader package of conditions.
The speech on Wednesday may remain a vision statement. The Guardian says detailed copyright changes aren't expected in it. Afterward, we can ask whether Albanese preserved the rejection of a text and data mining exemption, named a paid licensing mechanism, or left the issue open for another negotiation. Artists, unions, and labor factions don't share one position, and the eventual text will matter more than the pre-speech coalition.
There's also a geographic question beneath the legal one. Data centers can be built where land, power, permits, and political terms line up. Australian books and music remain Australian cultural output wherever a server is built. Trading a durable rights rule for movable capital would require a much stronger public accounting than the reported proposal has received so far.
And a creative fund can be generous in aggregate while distributing money badly. Who qualifies? Who measures use? Whether collective licensing covers independent work, and whether future creators can refuse all decide whether compensation is meaningful. A large annual number can't answer those questions by itself.
Indeed, Hiring Lab reports that US software development job postings rose almost 15% between Claude Code's launch in late February 2025 and June 2026, while overall postings fell 7%. That comparison has already been turned into a claim that coding agents created software jobs. Indeed itself says correlation doesn't establish that.
The composition is more revealing than the headline. Indeed says 71% of the increase between May 2025 and May 2026 came from senior roles, and 37% came from jobs with AI in the title. Those groups overlap. Companies appear to be asking for experienced people who can use or govern these systems. That offers little comfort to someone trying to get the first 2 years of experience.
Software postings also remain 27.5% below their pre-pandemic level. So we have a rebound from a depressed base, concentrated towards senior and AI-fluent roles, during the same period that agentic coding tools became widely available. Job postings aren't hires, employment, wages, or tenure. They tell us what employers are advertising, which is useful and incomplete.
I think the tools are increasing the amount of software some firms can imagine attempting while raising the premium on judgment. More projects can be proposed because implementation looks cheaper. Then the organization discovers it needs people who can define the work, inspect the agent's output, connect it to old systems, and accept responsibility when the result reaches a customer.
That red fits the data, but the data can't prove the mechanism. Interest rates, the broader tech cycle, and delayed hiring after the earlier contraction all sit in the same period. A stronger follow-up would separate entry-level, mid-career, and senior postings over time, then compare advertised pay and eventual hires. For now, the number complicates a simple job collapse forecast without refuting displacement.
It also makes the apprenticeship problem harder to dismiss. If agents absorb the small tasks that once taught junior developers how a system behaves, companies can demand senior judgment while weakening the path that produces it. A rising count of senior vacancies can coexist with a thinner profession 5 years later. Indeed's next few cuts by experience level will tell us more than another aggregate chart.
Machinecraft, a roughly 100-person factory in India, says it built Era, a 36-agent system supporting 9 front-office jobs. Rushab, who runs the company, gives the motive in one concrete detail. Knowledge about a 2019 quote or a strange custom machine tweak had passed through his grandfather's head, then his father's, and then his.
A machine factory accumulates exceptions. The drawing shows what was built. The quote shows what was promised. The payment schedule shows how the customer behaved. And the email may explain why an engineer changed the design. Retrieval from any one system misses the relationship among them. That makes the family history a much better starting point than, "We needed a company brain."
The talk says Era ingests years of quotes, drawings, payment schedules, timelines, and email, then organizes facts and relationships in layered memory. It has short working memory, pinned facts, episodic records, and a nightly consolidation process with a report of what was kept or discarded. These are the builder's descriptions, and the performance claims haven't been independently evaluated.
36 agents sounds impressive on a slide and tells me almost nothing about quality. The valuable boundary is simpler. Era drafts, human sends. People retain the act that creates an external commitment. I would still ask whether the person sees the supporting quote and drawing beside the draft, because approval without inspectable provenance becomes a ceremonial click.
The system's specialist agents each have a narrow job, and human corrections are stored so the same error is less likely to recur. Machinecraft has released what it calls Brain OS as a blank forkable architecture. Rushab says an agency quoted the company $230,000 to build the system. Again, that number comes from his talk, not a contract we've inspected.
Another company can fork Machinecraft's open-source software, but it can't copy the decisions behind it. It still has to decide which records are authoritative, whose corrections become durable, what deserves forgetting, and who can send. Those decisions are the company's memory policy. The model and agent count sit downstream of them.
Era stops before sending because a draft and a commitment are different operational states. That matches the earlier completion discussion without asking the factory case study to prove more than it does. The boundary is credible only if the person approving the message can see enough source material to judge it. The talk describes the authority split clearly. A fuller case study would show how often people reject drafts and why.
The nightly consolidation policy also needs to explain what Era forgets. Companies carry contradictions. The customer said one thing in 2019 and changed direction in 2024. A salesperson corrected a record for political reasons. An engineer knows a drawing was superseded. Memory sounds comforting until the system preserves the wrong version with greater confidence than any person would.
A release summary from Elvis Saravia describes LingBot VAV2, a video action model from Robiant that learns latent actions from unlabeled video and uses a sparse mixture of experts' video stream. The reported deployment work reduced latency per action chunk from 927 milliseconds to 142 milliseconds using 8-bit floating-point tensor RRT and a paged key-value cache.
That latency number gives the release its charge. A robot can't treat perception as an essay question. It has to observe motion, choose an action, and update before the physical scene has moved too far. Cutting most of a second down to roughly a seventh of one makes the control loop feel less like turn-taking and more like interaction.
The summary also reports adaptation from 10 to 15 demonstrations and a 93.6 average on RoboTwin 2.0. Those results come through one commentator's release thread, and a benchmark average doesn't establish industrial reliability. The technical proposition is narrower. Video pre-training may provide action-relevant knowledge, while sparse experts and serving optimizations make the resulting policy fast enough to test on physical tasks.
The 10 to 15 demonstration claim may matter more than the average if it survives outside the release setup. Factories and labs rarely have a giant labeled dataset for every peculiar object and fixture. A system that can absorb broad motion from video and then adapt with a small number of local demonstrations would change which tasks are economical to teach.
Independent runs on unfamiliar objects, clutter, camera changes, and recovery after a bad grasp would tell us how much of that promise carries into messy rooms. The paper and model give researchers something concrete to test. The reported serving reduction also reminds us that embodied intelligence is partly a deadline. The best action becomes the wrong action when it arrives after the object has moved.
Wednesday's Australian speech can clarify the copyright bargain. XAI can answer the repository upload findings, and independent LingBot tests can put the latency work beside recovery behavior. Each one needs a different witness because each one is making a different claim.
A green check can report that a test passed. It can't tell you who inspected the claim, what they inspected, or which risk remains. The people and systems that supply those missing facts will decide how much of today's abundant output anyone can safely use. Lenar.